Hey guys. So what I want to do in this video is I want to review with you how to balance a chemical equation. So remember, this unit is Unit 4, Chemical Reactions, and the first lesson ended by showing you the three types of equations that we're going to need to know: the net ionic equation, a complete ionic equation, and a molecular equation. The molecular equation is what we're most used to seeing. But the first step in writing any of these equations is to balance the equation. So this video, we're going to review that. So on the PowerPoint for lesson 1, there is an example for balancing chemical equations. I'm going to go through that example with you right now. So the example says methane gas, which is CH4, is burned in the presence of oxygen gas to produce carbon dioxide and water. Write the balanced molecular equation for this reaction. So if you look, the molecular equation is given to us below. And when we balance chemical equations, we're going to add coefficients in front of the compounds to make sure that the number of atoms of each element on the left side of the reaction is the same as the number of atoms of each element on the right side of the reaction. So to make this a little bit more clear, I'm going to rewrite the equation up top to give us space to add our coefficients. So here's the space, and we have CH4, which is a gas, plus O2, which is a gas, which is going to give us carbon dioxide and water. So the first thing we're going to do when we balance the chemical equation, we're going to split the reaction in half at the arrow. Then we're going to list all of the elements we have on the left side of the arrow. So on the left side, we have carbon, hydrogen, and oxygen. And I say the left side of the arrow, but if you notice, the left and the right side have the same elements. They might be in different places, but it's the same elements. Then we're going to count how many atoms of each element we have on the left side and then on the right side. So on the left side of the arrow for carbon, we have 1, because when there's no subscript next to carbon or next to any element, we know that it's 1. And how many carbons do we have on the right side of the equation? Again, we have 1. Now let's move to hydrogen. On the left side of the equation, right here, we have 4 hydrogen, and on the right side, we have 2 hydrogen, right there. Last, we're going to go through and count our oxygens. So on the left side of the equation, we have 2 oxygen, and on the right side, if you look, we have 2 right here, but we also have this one over there. So 2 plus 1 is going to give us 3. So all we did was we count how many atoms of each element is in the original equation. Now we know this equation isn't balanced because we don't have the same number of carbon, hydrogen, and oxygen on each side of the arrow. Because our hydrogen is already balanced, because our carbon is already balanced, we're going to move to hydrogen. Now, a good rule of thumb is to always balance hydrogen and oxygen last because they're going to change the most. Also, if you have an independent molecule, for example, O2, you want to balance that last as well because, again, it's going to change the most. So because our carbons are balanced, we're going to move to hydrogen. So if you notice on the left side of the arrow, we have 4 hydrogen, and on the right side, we have 2. We always go to the side with a smaller amount, so we're going to go to the right side, and we're going to add a coefficient in front of the hydrogen to try to get 4. So we're going to add a 2 right here. I'm going to erase my arrows so I don't confuse you. So because we added that 2, it's going to change how many hydrogens we have. So 2 times 2, we now have 4 hydrogens on the right side of the equation. But because we added this 2 and it's in front of H2O, we have to distribute that 2 to both the hydrogen and the oxygen. So that's going to change how many oxygens we have also. So if you look at how many oxygens we have now, we have 2 from the carbon dioxide, and then we have 2 from the water. So we now have 4 oxygens on the right side of the equation. So our carbons are balanced, our hydrogens are balanced. Lastly, we have to balance our oxygen. We go to the side with the smaller amount, which is the left side, and we want to try to make it so that we have 4 oxygen. So remember, the only way we can do this is by adding coefficients. So we're going to add a 2 in front of the oxygen, and that's going to change how many oxygens we have on the left side of the equation, making it 4. So if we now look at our work, this is our work right here. We have 1 carbon on each side of the arrow. We have 4 hydrogens on each side of the arrow, and we have 4 oxygens on each side of the arrow. So if I were to ask you, what are the coefficients that balance this equation? You would say the coefficients are 1, 2, 1, and 2. Where did I get that? If we go back to our equation, the coefficients that are in front of each compound are the ones that balance it. And if there's no coefficient in front, like methane, we didn't put a number in front of methane because we didn't need to, it's just a 1. So we have 1 from methane, 2 from oxygen, 1 from carbon dioxide, and 2 from water. So the coefficients that balance this equation are 1, 2, 1, and 2. So now in the example problems on the worksheets, you can use this method and balance every single one of those equations.